So, projectile motion. It is the movement of an object moving through the air with the effects of gravity in play. Just like how if you shoot an arrow in Minecraft, they are considered a projectile as they travel through the air and slowly fall back onto the ground. But to fully understand projectile motion, here are the things we have to take note of. Projectile motion is under kinematics, so we will be using the following kinematic equations that fits our projectile problems. The ones to the left are the main equations and to the right are the other formulas that can help you determine a given. Feel free to pause the video to copy the formulas. The horizontal and vertical component is independent of each other. Let's say a ball was thrown upwards and the vertical velocity of it starts at a positive value because it was thrown upwards and up is positive. But gravity is pulling that ball down until its velocity starts to go down to a 0 meters per second, which is the peak point. And that will be the turning point where the positive vertical velocity, where the arrows are upwards, it's now going to be downwards. And as the ball slowly goes down, it will then reach the ground. And because gravity is affecting the vertical velocity, it doesn't mean that it will also affect the horizontal velocity, which is the red arrows. They're independent of each other. If the blue goes up and goes down, it doesn't mean the red will change. It's unaffected. It's very independent from each other unless an external force suddenly appears. Next, when we're filling in the formula, all variables should use the same component. So as you can see in this Cartesian plane, we have the x-axis, which is here, and the y-axis, which is here. So each variable, example velocity or acceleration, they have their own components. So let's say we have a point here, and this is the velocity going to the right, and this is the velocity going up. So the velocity going to the right is the velocity in the x component, and then the one going to the up is the y component. So each variable like acceleration, distance, they all have their own certain component. So let's say we're trying to solve for velocity, let's say we're trying to solve for y direction, which is also basically known as height. We're trying to solve the height, let's say maybe the peak height. Since we're talking about the y component, all of the variables that we'll input into the formula are also of the y component. Y acceleration, y velocity, everything else that is y and not x. You get the point. There are some exceptions to this like time, because time doesn't have a direction unless we dive deeper into thermodynamics and microscopic physics. Let's not do that. It's going to be too complicated. And we know that time is just always positive, for this at least. If the problem we're trying to solve is free fall, which looks like this to the left, or let's say something that looks like this to the right, which isn't really free fall, but it is something that is close enough to it, because if you look at the y component, it is just going downwards, isn't it? It's not going up then going down, it's just going down. So if it's something about one direction only, just going down, then we don't need to assign any negative or positive signs for our given values, because just for computation's sake, it's either everything is positive or everything is negative. It won't matter because they're all going downwards anyways. And I've tried both and it actually works. It still works, trust me. Later in the video, I'll give one example of this to prove the point. However, when it comes to a problem with both positive and negative direction in play, let's say something like this. You have a positive direction here going up, then a negative direction going down. So it's two directions, isn't it? Up and down. Let's say at this point your velocity is positive, but at this side, your velocity will become negative because of gravity reducing the velocity as time goes by. Then if that's the case, you absolutely need to indicate all of the signs of each of the given if it's a negative value or a positive value, not like with the free fall one, because the free fall is just going down. It's one direction. It doesn't matter. But if it's something that's a concave curve, it's going up, then suddenly it's going down, then there are different values of given. There will be a positive given, there will be a negative given. Then you have to put every single one of the signs for it, or else your computation will be wrong once again. And that's how the rule where gravity is equal to negative acceleration, because we know that gravity is 9.8 meters per second squared, right? But since it's a force going downwards, just like this thing to the left, it's always negative. So if we're going to talk about acceleration because of gravity, then it's always going to be negative. Lastly, never forget to list down your given. Let's say Vy and Vx. Never forget to also put the component. If it's a x, a horizontal component, or y, a vertical component. Another one will be like Ay, which is like gravity, and then ax, which is probably another kind of acceleration depending on the problem that you have, and then maybe dx and then dy. As you can see, there's a lot of components and it will all depend to the problem that you'll be given. So now let's solve the two problems that we have. The first one is more on the technical side where we use a formula, and the second one is more on analysis. And I'll then be uploading a second part video where we cover solving projectile problems using quadratic formula. So now let's try to first solve this problem. Suppose a ball is projected from a height of 25 meters above the ground and is thrown with an initial horizontal velocity of 82.5 meters per second. A. How long is the ball in flight before striking the ground? And B. How far from the building does the ball strike the ground? Let's try to first solve the question A. First, let's try to illustrate what is happening here. So the ball is 25 meters high, and that will mean that, let's say, it falls from here. And then it is thrown with a horizontal velocity, so going like that. And then it slowly goes down until it strikes the ground. So it will look something like this. Simple, right? Let's just draw that to represent 25 meters. And now we're trying to figure out the time it takes before it strikes the ground. So let's write down the given. So dy, which is the height, 25 meters. Next, you have initial horizontal velocity. So horizontal, that is the x-axis, so x component. That is 8.25 meters per second. And then let's write the other components as well. So Vy is 0 because we didn't really have a vertical velocity going up or anything. It's just to the right and then it slowly falls down. We have Ay, which is gravity. So we know gravity is a negative value. So we'll put that there. We have Ax, but that's just 0, so we don't really need that. Well, just for the sake of this, let's put that. And then dx, that is what we're going to try to figure out later for question B, but for now, let's try to figure out the time. So how do we solve the time? So we have to look at the formulas that we have. So we're going to be using the y components, right? So let's just put an arrow at that so we will not be confused. Actually, let's put an underline. So dy, vy, and ay. So let's check in the formulas if the given we have can be used. So do we have dy? Yes, we do have dy. We can use that. Vi, yes, we have that. That is 0. Time, that's the one we're looking for, so that's perfect. We will be looking for time. So we have one component here that we are missing. Then a, we also have that, so perfect. We only have one variable that's missing, so we can use this formula. And the next one is let's try this. Can we use this? But there is vf, so we cannot really use that. We don't have the value for final velocity, also this and this, so we're really stuck for this one formula. These are the two are just for like straightforward given questions. Like let's say you're trying to find the velocity, but you only have the distance and the time for that specific velocity, then that specific point. But since we're looking for this solution overall, we're going to be looking at these four equations only. So now let's try to copy paste that. So now we have the formula here, and I've added the y component here so we won't be confused. We will try to isolate t here. However, it's on both sides, so it's going to be hard to isolate that. However, good for us in this problem, vi, or initial velocity, is equal to 0. So if this is equal to 0, this will be cancelled. So all of this is gone because 0 times anything is 0. So all we're left with is this. So let's try to rewrite that here. So now that we have this rewritten here in the bottom, we can try to isolate with t squared here, which is on the right side, we can isolate that now. So to move all of this to the other side, we just have to do division on all of them. So if you will divide a here, you also have to divide a here. So now it will become dy is all over a. And then for 1/2, it's just going to be the opposite. It's just going to be like that. Swaparoo. But one is, we can just make that invincible. So there you go. It's equal to t squared. Let's just write it down. But this is still t squared. This is not t. So to remove the square there, we can just put the square root. So do that on both sides, of course. And if you rewrite that again, it's good. It's only going to become, and there you go. So now that we have all of it simplified and rewritten, it's only t that's alone here, and that's what our missing value is. So we can just substitute this. It's very, very simple, isn't it? Square root 2 dy. dy is 25 meters. Let's put parentheses so that it's easy to indicate. And then ay is negative 9.8 meters per second squared. Looks like we have one small mistake here, and this is a good thing to take note of. Usually the distance is, we will think of it as positive, right? However, we're talking about the distance going down. The distance going down, so that's a negative value. So these are the kinds of small mistakes that you might encounter while you're trying to solve these things. So signs are very important here. And so let's put a negative. So if you try to use a calculator here, the answer that we will be getting is 2.26. Since this is time, it's going to be seconds. Because if you look at the given, it's only meters and seconds. So of course, we will be getting seconds. And that will be our answer for A. It's just that simple. But one thing to take note, just remember the one I told you a while ago. If it's if the diagram looks something like this, it's just going down here. It's just, one direction in the y component. So it's just like that. It looks like that. Because if you ignore the x component, which is the thing that makes it go to the right, it's only going down. So since it's like that, we can ignore the signs actually for this problem only. So if we try to put positive values instead, so positive 25, then positive 9.8, everything's positive, we will get the same result because anyways, negative divided by negative is just positive, isn't it? So it's just going to become the same answer. So this is something where as long as the signs are consistent, then it's not a problem. You don't really have to use negative signs. But if you want to be safe overall, I suggest to use the negative sign still. Now we can go on to our second question. How far from the building does the ball strike the ground? So this is what we're trying to find out. And that is distance x. So let's just put that here. Well, we already know what t squared t is, so we can write that down now. So with the formulas that we have, let's now choose another one. But this time, since we're looking at the distance x, we also have to use the x components. Let's write that all up. So we have 3x components here. We can also use time because there's no component for that. Time is time. So all of this are already eliminated because it's VF, right? We don't have VF. So the answer here is quite obvious. It's just that. You might notice that it might be a common formula to be used in physics if you don't have VF, because that's the only thing without VF. Alright, so let's isolate. Next step is isolation. Isolate dx because that's what we're looking for, and good for us, dx is already isolated. So there isn't really anything for us to worry about. We can just simply substitute it directly now. So dx is equal to initial velocity x, that's 8.25. Let's put the parenthesis, times t, 2.26 seconds, plus 1/2, let's move it here, 1/2 0 Then t squared, we don't really need to write all of this anymore because we already can see 0 here. So all of this is just cancelled. So it's just 8.25 times 2.26. So let's now put that in a calculator. So 8.25 times 2.26 is equal to 18.645 or 65. And our units here is meters. So that's the distance on how the ball traveled from here to here. That is 18.65 meters. So now we have fully solved this problem. We can now go into the next one. So on to problem number 2. A rabbit suddenly jumps vertically and reaches its peak height after 2 seconds. What was its jump's initial velocity? Let's first write down our given. We reached our peak height at 2 seconds, so assuming that there's no wind resistance, this will mean that it will also take 2 seconds for the rabbit to get back down to the ground from the peak height. So 2 plus 2 is equal to 4 seconds. That is our total time. Next, of course, we have acceleration due to gravity. So a sub y, that is negative 9.8. Next, of course, that's it. So we don't really have any other given. So, hey, maybe some of you will think that this is not enough to solve this problem. We don't have enough given to solve this. Well, actually, it's actually enough. Now let's make a velocity graph. Here we go. This is more an analysis, so we cannot really just solve it directly out of the box. You have to analyze this thing. If you know how acceleration works, it's basically the amount of velocity that will change for every second. So this means that gravity will reduce your velocity by 9.8 meters per second for every second. That's what the squared means. Meters per second for every second. So that's why you can see here the velocity change after the peak height is negative 9.8, negative 9.8. But if you follow that philosophy, it's actually like that for every single one, because that's the only acceleration we have. So we know that the velocity will be changed by negative 9.8 for every single second. So if you do the math, 0 minus 9.8, 0 minus 9.8 is equal to negative 9.8. And the negative 9.8 minus 9.8 is equal to negative 19.6. So we can just do the opposite for that. Since we're going to do the reverse, we'll just add 9.8. So this will become 9.8 meters per second. And then add another 9.8, that's 19.6 meters per second. You will notice that there's a kind of symmetry here. And that is because if we try to draw this problem, let's say the rabbit just jumps like that. Since there's no wind resistance, the only force that we have here is gravity. So we can say that gravity is pulling down here, and then once we reach our peak height, that's where it's 0 seconds. It will pull down again here and then here. So there's only one force that's going to make us have a change in velocity. So it's like there's this kind of symmetry here. Since it took us 2 seconds to reach the peak, it also means that it will take 2 seconds to go down. And vice versa, the same applies with velocity. As long as the ground is, just flat, it's leveled out, then there's this kind of symmetry. So the answer for this, what was its jump? The initial velocity is 19.6 meters per second. So we did not really have to solve anything. We just had to analyze it. And this might come up somewhere in a tricky situation, and it's good to know how you need to play around with the numbers yourself without actually using formulas. So I'll be uploading a second part video for projectile problems, but this time it will be more on the quadratic formula, where we can use that to solve a missing value, more like time. And I'll also be adding more examples there if you want to practice more about projectile problems. And if you enjoyed this video, if you learned something, then consider to like and subscribe to support this channel. Thank you. Bye-bye.